Hello coders, so welcome to my video. In the last video, we studied about the basics of the pipe. So you can read these points again if you don't know about pipes, or you can refer my last video about pipe. So in this video, we'll see like we have in second point, we have pipes are used in unidirectional communication. Okay, so what we have parent and child relation. Okay, so these are pipes are used between related processes. So for example, I have a child. So what I will do, I will take a string const char, and I will take the message underscore child is equal to hello from the child. Okay, and this I already have the descriptors fd1 0 for read and fd1 for write. So what I will do, I will write over here. So write, I will take fd1 first for writing, and then we have the message msg underscore child, and then we have string length of our msg underscore child. Okay, so this way we will be sending our message to the write descriptor. On the other side, from the parent side, what I will do, I will receive it. Okay, so I'll just copy and I will change this API to read, and FD is 0. Then we need a buffer to read this message. So I'll take this as a buffer, like I'll take char msg child buff. Okay, I'll take it to 55, make it 0, and then what I will do, I'll take it buff, and here what I have to do, I have to do the size of our buffer. So msg underscore child underscore buff. Okay, so here we are writing some data into the pipe, and we are reading from here. Okay, so I will close the rewrite descriptor here. So I'll take close and fd1. I have to close one. Okay, write descriptor in this process, and I have to close the read descriptor from this process, from the child process. Okay, so what will happen? I'll just compile it. GCC pipe. Right, take it like this, and I just run this binary. So I think I have not printed it. Let's print it when I read it. Okay, so we'll print our buffer over here. So buffer receive is equal to, here we'll take percentage s, then we have msg underscore child underscore buff. Okay, so just compile it again, and I'll run it. Okay, so you will get a message, hello from world. Okay, so this is a unidirectional communication. Okay, we can do, write over the parent and read from the child. Okay, so but we have two descriptors, FD10 and FD12. Okay, both are used for reading and writing. So can we sync these descriptor over to the two places so that they can communicate in bi-direction communication? Because this time we are using the unidirectional communication in which the child writes to the pipe and the parent reads from the pipe. Okay, so what I will do, I'll just remove this point. Okay, so when I write to the pipe, I okay. So what I have done here is, like, I have only one pipe, two descriptor, read and write. So both I'm using in both the processes, from the child process as well as in the parent process. So first, in the child process, what I'm doing, I'm writing in the pipe and I am reading from the pipe as well. Okay. Similarly, I am reading it from the pipe. So once it write, it reads it. Then I write the data into the pipe from the parent process and it will be read by the child process. So let's see how it works. Okay, so I'm just compiling it. Compiles fine. So I'll take, you see, it got hanged. It got hangs. Let's write. When this buffer writes, then I'll take a sleep in between. So I'll take a sleep for 1 second, and here I will take a sleep between them so that it can read properly. So it won't go into the stuck state. Okay. So you see here, you get a read descriptor 3 and 4 buffer received from child. Okay. Hello from child. So then the program ended, and then we have receive from parent, and it is given hello from parent and program ended. Okay. So let's do one more thing. Let's stop this process so that it won't interfere in other process. So I will take exit from here, exit success. Okay. And next, what I will do, I will wait for the process, for the child process to complete. So like this, then I again compile it. So you see here, you will get buffer received from child, hello from child, and buffer received from parent, hello from parent, and the program ended because the child always exited. So it is like that. What we conclude from here is, if you are not syncing this data, this will go in a stuck state. Okay. So how to resolve this? Okay. So now next thing is how to resolve it. So in spite we are using a single pipe, there are chances that the data is overwritten or got corrupted. Okay, so here I'm using very small amount of data, so that's why it's coming properly for syncing. But there may be a problem with this data if you are not syncing it. Okay, so to resolve this unidirectional issue of the pipe, what we can do is we can remove this sleep and remove this as well. Okay, let's wait for here and now what I will do, I will not sync it, rather I'll create a new pipe out of this. So I will take a new pipe, for example, 2 here. Okay, so similarly, I will take FD2 here and I will print FD2, 2, and here also. Okay, then what I will do, I will write through FD1 and read from FD2. Okay, and similarly, we will be doing the same thing in here. So reading is through FD1. Similarly, okay, so this one is FD1, write is from FD1, so read I will do for FD1 only. Okay, and write read is here is FD2, so I will be doing FD2 here. Okay, so let's save it. Let's compile it once. Okay, so now you see there is no task that is stuck. Okay, so they are giving value every time and the program is fast as well. It's not waiting, it's not stucking, so they are less prone to errors. Okay, so this is an example of a bidirectional pipe that we can use to resolve the problem of unidirectional communication in case of the pipe.